basically this part of 2.5 is everything we've done so far is basically taking the polynomial apart and breaking it up and factoring everything out and finding all the zeros. Whereas now, basically what's going to happen is we're going to put everything back together. Okay? So we took everything apart for essentially 4.5 sections. Now we're going to put it back together in a half a section. So all we're going to do is they're going to give you zeros. So we're going to give you the solutions, and then we have to write the polynomial. Now, it will tell you what type of polynomial you are going to have. So like it's going to tell you what the degree is. It will also tell you, it'll give you like a reference point in case you have another value or another number as far as like what one of the points is on your graph. Because you have to know not every function or not every polynomial is going to be x to the fourth, x to the third. It may have a number out there. It may have like the a value or the scale fact, that can cause a lot more movement in our graph. It's like I can take this ball and I can drop it and everything happens, or I can do that and it's going to move a lot more, right? Same idea. I can drop it really slow and do everything, or I can just drop it regular and nothing changes. Okay? So I've got to figure out what's happening. Is it going really slow? Is it going really fast? Things like that with that a value. Okay? But we'll get to that in kind of just a second. So whenever I have a fourth degree polynomial, the biggest thing is they will give us at least a certain amount of real coefficients, and then they may give us an imaginary number. So there are times, like in this case, like on 6, that it says find a fourth degree polynomial. So that means my power is going to be to the fourth power. Okay? But what they give me is only 2 real values, and then it says that I as a 0. Well, whenever we have an I, that means we're also going to have a negative I. Okay? So anytime you have an imaginary number, you're going to have the conjugate of it. So if I have like a positive I as a solution, then that means I'm going to have a negative I as a solution as well. Okay? So if I'm writing these all as linear values, okay, it's basically like I'm going to take it from the step right before it. So if I have a negative 2, then that means I'm going to have x plus 2. So if I have a solution of x minus 2, then I'm going to have a linear equation or linear expression of the opposite sign. Same way, if I have a value of 2, then I'm going to have x minus 2. Same way with the I. I'm still going to have x minus I, and I'm going to have x plus I. Now, what I would tell you with any of these is to always kind of, like for me, I would put this together. Okay, I'm going to have an a, but I'll get to that in a second. Okay, if I'm going to really rewrite this, I'm going to have y equals a. Okay, I'll get to that in a minute though. Okay, as far as in terms of finding a. So I'm going to do the real values first, or together, and then I'm going to do the imaginary values together. So whenever I do this, if I'm going to take x plus 2 times x minus 2, what is this first part right here going to turn into? What's x minus 2 times x plus 2? X squared minus 4. Okay, it's just a difference of, okay, they're conjugates, so it's just going to be, it's really a difference of 2 squares. Okay, if I do the same thing then for my I values, they're conjugates of one another. So just like I did before, I did x times x and I got x squared. Okay, so x times x is still x squared. What's going to be negative I times positive I? Negative I squared, right? What is I squared? Negative 1. So what is negative of a negative 1? Plus 1. So I really have x squared plus 1 times x squared minus 4. Still have the y, still have the a. We'll get to that in a second. Okay. So if I go here, I'm going to go ahead and multiply these two values. So x squared and x squared is going to be x to the 4th plus x squared minus 4x squared minus 4. Does everybody see what I just FOILed, multiplied, whatever? Okay. I still have the y equals a. Okay. I just kind of bring it down because I'm going to figure out what a is here in a second. So if I combine like terms, I have y equals a times x to the 4th minus 3x squared minus 4. Now, I'm not completely finished because I haven't completely rewritten my polynomial. Now, I am in pretty good shape because it's a 4th degree. That's what I want. Okay, I just have to figure out, do I need to multiply everything through by a common value? So I have to use, okay, there's a reason why they give me these two values. Okay, what's the 3 represent, the x or the y? The x. What does the negative 150 represent? The y. So all I'm going to do is I'm going to take, this is my x, that's my y. I'm just going to solve for a. So I'm going to have negative 150 equals a. Now in here, I'm going to have 3 to the 4th power minus 3 times 3 squared minus 4. So 3 to the 4th is 81. 81 minus 27 minus 4. So 81 minus 27 minus 4. I have a, so I have negative 150 equals a times 50. So what's my a value? What do I need to do? Divide by 50. So a is equal to negative 3. Now, all I have to do with that a, okay, all I have to do is take that a, and I'm just going to replace it and put it right here. So it's kind of like I'm going to kind of go back in the middle part, and I'm going to rewrite everything back out. So if I have negative 3, so if I have y equals negative 3 times x to the 4th minus 3x squared minus 4, just distribute that negative 3 back into everything inside. So what is my actual function? Well, it's negative 3x to the 4th plus 9x squared plus 12. Now, to be honest with you, you can really, there are probably about 3 different places you can put in this 3 and this negative 150. You could probably put it in for the green part. You could put it in for the purple part, or whatever color we're calling that, or you can put it into the orange part where we put it in here. It's really up to you. It really doesn't make a whole lot of difference, okay? Because we're still going to have a negative 150. We would still have 9 minus 4 in here and have 5. We'd have 9 plus 1 and have 10. We're still going to get a 50 if we plug it in here in kind of like the green and the blue, or if we plug it in here with the purple. It's really up to you as far as wherever you see fit, you can plug in that A value, or the X and the Y to find A, really at any point in here. Okay? It's really up to you. I'll have some students that just to be perfectly honest with you, right here is where they'll put it because the numbers are a heck of a lot easier to deal with. Okay? 5 times 10 is a lot easier to deal with than 81 minus 27 minus 4. Okay? Just to be perfectly honest with you. Okay? But it's really up to you. I usually put it in the first or the last one first and then tell you you can go anywhere with it. Because then the biggest thing is if I put it up here in the green one, I've got to make sure that I continue to multiply everything back through whenever I get my A. Does that make sense? It's Descartes, okay? It looks like Descartes. It's really Descartes' rule of sign. Basically what that means is if you go through your entire polynomial, okay, and you look to see how many times there is a sign change. Okay? So understand, you always look at the very first term. So it goes from positive to negative, then nothing happens because it goes negative to negative, so there's not a change. Negative to positive, still a positive, and then positive to negative. Okay? What that will do is tell you the type of real zeros that you're going to have. So it's going to tell you if you're going to have any sort of imaginary numbers. Does that make sense? Okay. So if I have 3 sign changes here, and it's to the 7th power, how many imaginary numbers am I going to have? Or how many real numbers am I going to have? Let's look at it that way. 1, 2, 3 real numbers. So if there are 7 solutions, how many of those are going to be imaginary? 4, right? It's just simple math. Okay? So basically what this says, okay, so if it is the number of positive real zeros of f is either the same as the number of the sign changes, or you can basically less than the number of sign changes if it's an even integer. Okay? So in your sign right here, this table, if you're going to draw anything, this is going to be your best bet. So it talks about 3 sign changes. Okay? So then there are going to be 3 positive real zeros. Okay? Or you can look at it as like 3 minus 2 is going to be 1 positive real zero. Okay? So you can kind of go from there as terms of the positive real zeros. Okay? So it changes twice, so there are going to be 2 positive real zeros. Okay? There's only 1 sign change, so there's just going to be 1 positive real zero. Okay? It only is going to go to the one that is basically adjacent to it, so it's going to be the next sign. Okay?